Hello everyone, my name is Ahmed. I work for Avionics and I am a senior Linux and DevOps engineer. In this video, we are going to talk about a trending topic that was the buzzword in the last few years. Yes, you guessed it, DevOps. So, DevOps is all about automation. It's about how you can hand the repetitive task that you do as a developer or as an operator or as a system administrator to some clever tools that are going to ensure efficiency and accuracy while performing those tasks with little or no human intervention at all. Each year there are more and more DevOps tools that come to existence. In this short video we are going to cover some of the most important ones that you will need to master in 2018. So let's get started. The first tool in our list is Jenkins. When we talk about continuous integration or continuous delivery or continuous deployment, we can never complete this talk without talking about Jenkins, the invaluable tool that will act as the central gear in any DevOps project that you work with. Jenkins is very easy to use. It has a GUI. It has very little prerequisites, actually all what you need to run Jenkins on any machine, Windows, Linux, Unix, Mac OS, any OS that you can think of. The only prerequisite that you need is Java. Just a modern version of Java and you are all set to use Jenkins. Once set up, you can do all sorts of continuous integration tasks, like for example, polling a central repository like on GitHub or your own private Git repository, whether it was local in your own environment or in the cloud like on Amazon, for example, or whatever cloud provider you use. You can pull the latest code from this central repository. Then you can do all sorts of tests and automation and automate all sorts of quality assurance on that code. Then you can test integration with other components of your project, like for example, the backend database, the middleware, if you have a queuing or messaging server and so on. You test all these components together. Everything in this workflow is done automatically for you. Jenkins handles everything for you. Then you can deploy or deliver this code, deliver the final artifact to a staging environment or a user acceptance environment or even production, which is called continuous deployment. All of this is done automatically without any human intervention. It will also inform the developers or whoever is responsible that there are errors that happen during the integration process or that there was something wrong that needs human intervention. Then whoever is responsible for this is going to intervene, correct any errors, and get back the project on track. Now imagine the amount of time and effort that can be saved by using such a tool. Jenkins is just indispensable when working in any DevOps environment. In 2018, make sure that you learn about Jenkins. Make sure that you cover at least the basics of this amazing tool. The second tool in our list is Vagrant. Now, what is Vagrant? If you have read about Vagrant before, or if you come to hear someone talking about it, you might hear that it is a virtualization platform just like VirtualBox or VMware or Parallel. That is very far from the truth. Actually, Vagrant works upon those virtualization platforms. If you have VMware, if you have VirtualBox, you can install Vagrant on top of those platforms. So what's the difference? Why use a tool such as Vagrant when you already have VirtualBox, when you already have VMware, for example? The reason to use Vagrant is that you are going to write your infrastructure. You're going to build your infrastructure using code the same way you build your applications. Isn't that just amazing? Yes, you can just write a document written in Ruby, which is a very famous programming language. It's a scripting language as well. You just write or describe how your machine should look like, what kind of network model it's going to follow, what kind of connectivity it's going to have, whether it will be behind a NAT, whether it's going to be inside an isolated environment, whether it's going to be live, whether it's going to reach each and every other machine in your network. All of this is configured inside this Ruby file. Let's call it a Vagrant file. Then you can configure what sort of application or what sort of runtime that gets installed on this machine. Let's say, for example, that you are building the MEAN stack, which stands for, of course, MongoDB, Express.js, AngularJS, and Node.js. It's a very famous full-stack JavaScript web framework that is well suited to real-time applications like gaming and chatting and other real-time applications. So what if you need the prerequisites required for building such a stack? Your developers or your team is asking you to quickly spawn an environment that will be ready to host an application that is built on the MEAN stack. If you are using virtual machines, you are going to spend a lot of time downloading the ISO file for Ubuntu or CentOS, then start installing this operating system, then start creating the necessary users on the machine, installing libraries, configuring permissions, ensuring that the correct versions of the prerequisites are installed, the correct version of Node.js, the correct version of Express. If there are other prerequisites, you need to ensure that they are all installed and configured correctly so that developers or whoever is going to come after you to start working or start building the application finds everything he or she needs. Now imagine the amount of time and effort this task takes from you. Now what if the next day or the next week you are asked to clone this environment, create a typical environment in some other location? Let's say that you need more than one testing environment. UAT or user acceptance and a staging, and then another staging environment, another testing environment, quality assurance. If you are in the field, you know the pain of such requirements. You build numerous environments in a week or in a month. Using a software like VirtualBox or VMware, you will have to do the very same steps each and every time you are building an infrastructure. You will have to reinstall the OS. You will have to recreate the users. Yes, you may use shell scripts for this, and that is perfectly fine. But again, this is error-prone. This is time-consuming. Vagrant will cut all this for you. It will create something that is called a box. A box contains an already installed operating system, optionally with some prerequisites already installed. So for example, you can download a box that contains CentOS, built upon it Apache, for example, or Node, or Nginx, or MongoDB, for example. You don't have to install it. You don't have to configure it. It's already configured for you with the default users, with the default configuration. It's all in place for you. Then you can combine Vagrant with a configuration management tool like Ansible or Chef or Puppet or Salt or even a shell script to further customize your environment, to further configure the required libraries and dependencies and so on. Now imagine again the amount of time and effort that is going to be saved by using Vagrant. All what you need to do is write a Vagrant file with a very well-known and well-established language like Ruby, and then you just issue a command like Vagrant up and everything is up and running. You can spawn multiple machines, like dozens of machines using Vagrant, and they are all going to be created for you in a matter of seconds. So again, in 2018, Vagrant is one of the most important tools that you need to master. Now, speaking of configuration management tools, I have already mentioned configuration management when I talked about Vagrant, but maybe some of you are not aware of configuration management. Configuration management, or CM for short, is a way of describing your infrastructure, is a way of, instead of dictating commands, instead of writing scripts, whether they were in a programming language or in native bash scripts. Like for example, if I want to create 10 users and then each of those users is going to have access to a specific directory, and then this directory is going to have a number of libraries or a number of software components. All of these are requirements to a specific model or a specific environment. There needs to be a way to not only automate creating this environment, but also ensuring that whenever this environment has something wrong, whenever this configuration deviates from the model that you want, using just one command, you are going to bring your environment back to the way it was. If one user gets deleted by accident, you don't have to know which user was deleted. If the environment is not running as expected, all what you have to do is just run the tool against your environment, and it will ensure that your environment will get back to the way it should be. Whether a library was deleted, a permission was misconfigured, a user was deleted, no matter what happened, the tool is responsible for bringing back your environment to the way it should be. One of the very famous tools in this field are Ansible. Ansible is a serverless tool. This means that you don't need a central server to run Ansible. Just run it on your local machine, on your local laptop, and it's going to connect to your target machines. Whether they were a few machines like 2 or 3 or even 10, up to dozens, even hundreds or thousands of machines. Everything is done through the famous protocol SSH. So you don't need to open even new ports on your firewall. Port 22 for SSH is already open in each and every environment that uses Linux. So there is no configuration that needs to be done on the firewall. There is no agent that needs to be installed on the target server, just Python, which probably is installed on each and every Linux and Unix system I am aware of. And Ansible should be installed just on your local laptop. It's like you are managing your infrastructure the way you are doing. You are not doing anything more than what you are already doing. You're just installing a tool on your laptop that is Ansible, and it's gonna do whatever you want on your target machines using a file, a description file or an instructions file. Ansible calls it playbook. This playbook is going to ensure that your infrastructure, your environment is always at the state that you want it to be at. But Ansible is not the only tool in the market that does this thing. Although it does it very well, I personally prefer Ansible as my own configuration management tool, but that doesn't mean that there aren't other tools in the market that are equally efficient and offer a lot of powerful features of their own. One of which is Chef. Chef is a configuration management tool that uses Ruby as its domain-specific language, so if you are a Ruby programmer or if you have background about Ruby, you will feel right at home. If you don't know about Ruby, that's perfectly okay. Chef is very easy to understand and to adopt. Chef uses Essential Server. That might be an advantage for some people and a disadvantage for others. Well, depending on your configuration, Essential Server might be very important, because now imagine that you have like 1,000 or 2,000 servers and you want to push an update on all those servers at the same time. Like, for example, you just want to install the newer version of Apache, or you want to install a newer version of a library that Node.js uses. Now, if you are using a software like Ansible, you might feel that it's kind of overwhelming to have to wait till Ansible pushes all the updates on all the machines. Somebody has to be available on the tool to monitor whether or not all the servers have connectivity, if something failed or something. Using Essential Server may be a good choice in this case, because Essential Server will ensure that all the updates are pushed to the respective targets. And if something wrong happens, you'll always have a dashboard or a GUI where you see where the error happened or which node did not get the updates in time, and so on. Okay, somebody, if you are aware of Ansible already, somebody is going to argue with me that, okay, Ansible has Ansible Tower, which is also a dashboard that is used to monitor workflow of Ansible, and again, it's going to tell you which things got right and which got wrong and so on. It's up to you at the end. I'm just giving you the tools, and it's up to you to choose the best for your environment and for your project, or you can use multiple tools at the same time. There is nothing wrong with using multiple tools in the same environment. And I couldn't leave configuration management without speaking about one of the very well-established tools, which is Puppet. Puppet is also a tool that uses Ruby as its domain-specific language. As I said, it is very well established, it is very powerful, it contains a lot of features and a lot of tools that are going to ensure that whatever tasks you want to achieve on your target servers are done. Now, let's leave for a moment configuration management tools and talk about one of the promising topics in DevOps, or one of the most talked about topics in DevOps, which is containerization. Now, some of you are aware of containerization, some of you are not aware of containerization. So for those folks, let's talk a little about containerization. A container is nothing more than a bundle of files, libraries, and some sort of configuration that dictates how these libraries and files work together. A container is not a virtual machine. It will act like one, but it's not a virtual machine. Actually, a container, the beauty of containers is that they share the resources of the underlying OS. So if you have a virtual machine or a physical server and you want to deploy, again, the mean stack, you can use a tool like Vagrant to spawn 4 virtual machines, one for a web server, another for the application server that's going to host the Node.js server, a third for the backend database, MongoDB, a fourth maybe for a load balancer or something. You have 4 virtual machines to correctly have a mean stack. But what if you only have one machine and you are not willing, or you don't have enough resources to create 4 virtual machines with their own CPUs, with their own disks, with their own memory, with their own I/O, and so on? A container will solve this issue for you. A container will share the resources of the same OS with other containers. So given a physical server or a virtual machine, you can create 4 containers. Each of them is holding a component. Some of you might call this model microservices model. Yes, you are totally correct. This is the microservices architecture, and microservices is one of the trending topics also in 2018, which is breaking up your application into modular atomic components that interact together or interact with each other with some sort of a protocol, like REST, for example, or SOAP, or whatever protocol you are using. The most important thing is they are not tightly coupled together. They are not totally dependent on each other. Each of them can work independently, and containerization is a perfect tool to achieve a microservices model. As I said, you can create multiple containers. You can create a container for your web server, another for your load balancer, a third for your application, a fourth for your backend database. Docker is one of the most well-known containerization software in the market. Docker is very easy to install, it's very easy to understand and use, and it works nowadays on Linux and also on Windows, and that makes it highly interoperable. You can move your containers from Windows to Linux and the other way around. That makes it very, very efficient. And again, it is an invaluable tool to be learned and mastered in 2018. And how come we talk about the trending DevOps topics of 2018 and leave version control? Version control is indispensable whether you're working as a developer or as a DevOps engineer or as a system administrator or just as anybody who works with text files. Version control cannot be left behind. Version control is something that you must incorporate into each and every project that you work in. Some of you do not use version control at all. Some of you are not aware of its existence at all. So for those folks, let's have a quick introduction to what version control is. Now imagine that you are a developer working in a project with a team of other developers. The source code, let's say it's C or Java or Python or whatever language you are using. It contains multiple source files. Each and every developer of you must have naturally a copy of those source files. Start working on the project, to start writing code, start creating features, start testing, and so on. But each and every developer is working on his or her own piece of code. Alright, somebody, if it's a web application, for example, somebody is working on the front page, somebody is working on the about page, somebody is working on the user authentication page, and so on. But at the end, this code must be merged together in order for the application to be tested, for example. So how is this gonna happen? Well, the way I see it is that each and every developer will have his or her own copy compared with the other versions that are with other developers, and then some sort of copying and pasting may occur so that the whole application is brought together and tested. Imagine the pain of doing this. Now, what if something wrong happened and you want to revert to the older version of the application or the website? You want to get back a couple of steps. If you were not cautious and didn't take a backup of your application, you'll be in a big problem. You will have to maybe rewrite the whole application again. This is a lot of time to waste, a lot of effort. Version control will give you a way to track your changes, a way to keep branches of your code that you can switch from one branch to another. If you want to add a new feature and you don't want to mess with the master code or the main code of the application, you can just create a new branch for yourself, work on it, test it, and once you are sure that everything is working correctly and that the application is working as it should be, you can merge those changes, of course, with the appropriate permissions and the appropriate supervision from whoever is responsible for supervising the whole application. You can merge those changes back to the master code. Also, each and every developer can have the newest copy of code downloaded from what's called the repository, the version control repository. So you will always have the latest code, so you can continue from where your fellow developers left. That is just very efficient, and that's why version control is indispensable for every developer or every system administrator or just anybody who's working with text files. So what are the most well-known version control tools in the market? Goes without saying, it's Git. Git is very efficient, it's very powerful, and some people may confuse Git with GitHub. Actually, they're totally different things. Git is the tool that is used for version control. You can use Git to create a Git repository of your own, and GitHub is just a service, a web application that is hosted on the internet, and it is used to provide free and paid Git repositories for its users. If you have your project hosted on GitHub, other developers worldwide can fork this application or this code, create new versions of it, notify you about some, for example, bugs or suggested enhancements and so on. So this is just how open source software works, like by applications like GitHub. But GitHub is not the only web application that serves this need. There are other tools in the market or other applications in the market, like for example Bitbucket. So Git and GitHub are totally different things, but they are somewhat related to each other. Git is the tool, GitHub is the service. So let's quickly recap what we mentioned in this short video about the tools that you will need to master in order to start or enhance your career as a DevOps engineer. First, we have Jenkins for continuous deployment and continuous integration. We have Vagrant for instant provisioning. We have configuration management tools like Ansible, Chef, and Puppet. We have containerization tools like, of course, Docker. And finally, we have version control tools, the most well-known of which is Git. Okay, I hope you enjoyed this video. My name is Ahmed for Adionics, and thank you for watching.